All right, so the last main feature of rational functions that we're going to talk about is slant asymptotes or oblique asymptotes. So some rational functions will have oblique or slant asymptotes. And basically this happens in a very specific case where the degree of the numerator, the top, is one higher, one more than the degree of the denominator at the bottom. When that happens, it's going to have a slant asymptote. So it might look, let's say here, let's see, we've got our coordinate axes, and let's say we have a vertical asymptote here, and a slant asymptote is going to be just some kind of, just a line, right? And then our function might look something like this, like here is basically constrained by those two asymptotes. So when that happens, we would say that f of x is approaching some mx plus b as x goes to infinity and or as x goes to negative infinity. Note that a function cannot have both the horizontal and a slant asymptote, so one or the other, not both. Of course, that happens because you're only going to get a horizontal asymptote if the degree is the same between the numerator and the denominator, or if the denominator is higher. Slant's only going to happen when the numerator is higher. So how do we find these? Well, you've been practicing all chapter, right? You're going to do polynomial division. So the quotient without the remainder will give the equation of the slant asymptote. Okay, you're only going to have this with linear factors in the denominator, but we can do it with anything. Okay, so here we look at this one and we say, okay, great. What's our domain going to be? And we can say that numerator is not going to factor. So we need to throw out x equals 2 from our domain. That's the only thing. We can figure out where our x-intercepts are from our quadratic formula, right? Quadratic formula for the numerator, we would have negative 3 plus or minus square root of negative 3 squared, so 9 minus 4 times 2 times negative 1, all over 2a. So we've got 3 plus or minus root 17 over 4. Those are lovely numbers, right? I'm just going to write them like that. 3 plus or minus root 17 over 4, comma 0. So those are these two lovely numbers right here. Y-intercept, of course, we're just going to say 0, comma 1/2, right? Because that's going to be what I get when I plug in 0, top and bottom. We know that we have a vertical asymptote at x equals 2. We can see that I've already got the drawing out here. And we would find our slant asymptote because we see we've got degree 2 in the numerator and degree 1 in the denominator. So we can say our slant, oops. Oh, wait, let's go the other way. Sorry about that. Slant asymptote. We're going to do a division, right? We're going to say, well, I'm dividing 2x squared minus 3x minus 1, dividing that by x minus 2. So I can use synthetic division for this. There's no missing terms. So let's see, we got 1, 2, 1, right? So here's the equation of our line for our slant asymptote. We're going to have y equals 2x plus 1, which we can see, right? There's our y-intercept over 1 up 2 over 1 up 2. So there we go. So next up, we'll just work a few more examples in the next videos.